the original speaker, Dr. Richard Newcombe, is unable to come due to some reasons. So his colleague, Prince Gupta, who is a research product manager at Meta, will be presenting his talk, Introduction to Multimodal Perception with Project Area. Now, take it away. Thank you.
Thank you, Chen Cheng. Hello, all. My name is Prince Gupta. I'm a research product manager at Meta Reality Lab Research. As Chen Cheng was saying, Richard Newcombe was going to give this talk today, but he couldn't be here, so I'm representing him and our team's work here today. In today's talk, I'm going to be talking about, first, we'll give you an overview of what is Project Aria and what was the motivation behind creating Project Aria. And then I'll give you a couple of examples of audio research using Project Aria to motivate your own research. We are in a personal computing revolution. This personal computing revolution, of course, started with PCs, and then it went into smartphones. And today, of course, every one of us have one of these smartphones in our pockets. In fact, if somebody doesn't have one, can raise their hands, right? Now, what is the next step of this revolution? The next step of this revolution is VR and AR devices. This is a quote from Meta CTO, Boz, and he says, the defining quality of the metaverse will be presence, the feeling of being there with people, and Reality Labs is focused on building products that deliver presence across digital spaces for years. Now, what are the ways in which this digital presence can be delivered? One way is this, is by actually creating very accurate 3D representation of spaces. So this is Boz and his dad in a space which is reconstructed. And this looks very realistic, but there's still something missing from this. And that missing element is our egocentric perspective. How do we connect what humans see by themselves and actually bring that to AI assistant and smart digital assistants on these AR and VR glasses? So what we have today is an egocentric AI gap for this revolution of VR and AR devices. Our team inside Reality Labs Research is building a product called Live Maps. Live Maps is a physically predictive, live and updating representation of reality. This is how we're going to solve this egocentric AI gap. To build live maps, what's the way of building this representation of the world? You know, we could look at satellite data, which has been traditionally used to map spaces and used in navigation. Well, satellite data is only limited to outdoor scenes and has a limited resolution. We could go to a fleet of cars, and you must have seen several of these cars mapping the streets of various cities where teams who are working on autonomous driving cars are working. Well, even a fleet of cars is limited to outdoor spaces as well. Or you could go to a backpack rig, and our team and others have used backpack rigs. Now you can go to indoor spaces as well and get pretty high quality data, but it is still very limited in the type of activities that you could do while wearing a heavy backpack rig and the type of spaces and environments that you could go in. What you really need is this, a true and accurate representation of humans using these devices, wearing AR glasses in the future, and actually performing daily life activities in a very plural and realistic sense. So for this, what you need is very high quality data. You need to be able to collect that data in very diverse environments. And you need to have users do very realistic daily life activities like walking down the road, running on a treadmill. Now, there are unique challenges to collecting this kind of a data, which is egocentric data. You might be very familiar with these kind of challenges. The unique challenges are, of course, the scene scale, diversity, and realism in collecting real data in large scale. And then the devices that can be used to collect this data are glasses which are limited in compute, they're limited in sensing capabilities, and then they also suffer from high dynamic range and also motion. In fact, other challenges that come when collecting egocentric data are that there could be multiple frames of references when collecting such data. For example, visual frame of reference, if you are in a lift, might not match with your inertial data that you're getting at that time. And collecting egocentric data is uniquely personal and involves bystanders as well. So you need to make sure that you're taking care of both the privacy of the users and the privacy of the bystanders as well. So if you look at what are our option space for collecting such data, the option space can be mapped across these two axes. The first axis is the device capabilities. How rich sensor suite can be there. So you look at devices like HoloLens or Meta's Quest device line. Of course, these devices provide rich sensor suite, but they sacrifice on form factor. On the other hand, you could look at devices like GoPro or Vuzix classes. They have a good form factor that can be worn for long durations of time, but they don't have a good sensor suite. They lack the sensing capabilities. So what we identified is this gap in the market where we need rich sensor suite data, but in an all-day wearable form factor. For that, that's why we introduced Project Aria. Project Aria are glasses form factor which have a suite of rich sensors packed into a glasses form factor that can collect this egocentric data. These are Project Aria devices. In fact, I'm going to ask my colleague to also pass around one of these glasses so you can take a look and actually see how these glasses are. Project Aria is a research tool. It is not a consumer device. It is not a prototype. It is a research tool which allows us to collect this multimodal egocentric data to progress on research which is needed to build this revolution of personal computing by building future AR and VR devices. Now, when you look at Project Aria devices, there are two ways in which you can interact or partner with Project Aria to get capabilities that Project Aria offers. The two ways are, one, open resources that we have, and second, as a Project Aria academic partner. Inside of open resources, we've published open data sets and also open source tooling. The data set, you can go to this link to actually download the data set. It has multimodal data set of different types of activities, which is all collected through the different sensors which are on the glasses and has been fully annotated and labeled as well as anonymized for PII information. There is a set of data tools which is open sourced on GitHub. This provides C++ and Python bindings such that you can interact with the data set and be able to visualize or use those data sets in your own research. The second way of interacting with or partnering with Project Aria is through our academic partner program. If you partner with the academic partner program, then you get the devices and the tooling and also machine perception services. What is in these devices? These devices, as I mentioned, have a rich sensor suite. They have two SLAM tracking cameras, outward facing, one outward facing RGB camera, two inward facing eye tracking cameras, two IMUs, barometer, magnetometer, Bluetooth, Wi-Fi, GPS, 7 microphones to capture spatial audio, all this packed into a wearable form factor that you can wear and do normal day activities. As part of the Aria Research Kit, along with these devices, you would also get access to the tools. The tools include two different things. First is a mobile companion app that can be used to control the device. You can connect your Aria glasses with that companion app and start and stop recording. And also a desktop app which allows you as a university researcher to be able to download data directly from the glasses to your PC via that desktop app. Now, the unique thing about Project Aria is that in addition to the glasses and the various tools to be able to access and use the data coming from the glasses, you could also get access to machine perception services. Two particular ones that we want to highlight here today are trajectories, very accurate 6-drop trajectories, and eye gaze vectors. Both these machine perception services could be accessed via the desktop app, which allows you, to convert the recordings and generate the 6-drop eye gaze vectors, the 6-drop trajectories, and the eye gaze vectors from those VRS recordings. So these videos show, how you would actually go about in the desktop app go about and convert those so you can generate those machine perception services. The trajectory specifically, I wanted to call out, this shows a visualization of what is the tech behind generating those 6-stop trajectories. The tech behind generating those 6-stop trajectories has been tested across various indoors and outdoor scenarios. It is a very robust technology that our research team has pioneered. And this just shows you, one example of how under the hood it actually works. And if you get the glasses, you can record the data and actually get these very accurate 6-stop trajectories that could be used for doing additional research on top of it. Okay, so that summarizes what is Project ARIA devices and what are the different tools and machine perception services that you could get access to as part of the ARIA Academic Partner Program. Now, let me give you a couple of examples of what are audio research that could be done with Project ARIA devices. This work is a representation of work which has been done by the audio team inside the Reality Labs research division. Let me play this video first. Can we get audio?
Yeah, in a second, okay? This is our audio. Where is yours?
This? No. No, this is Mac, right? So it doesn't have. No.
You got the connections?
Oh, over here. Over here.
Okay. Let's start again.
It is quite funny if audio doesn't work in an audio workshop. Just search for audio research from Meta Reality Labs research. Essentially, if you want to do audio research from an egocentric perspective, this is what a typical lab setup looks like, right? So you have these different sound sources and the human among those sound sources. But an egocentric perspective with rich sensor input looks very different from that. In that you actually have multimodal data, for example, even visual information and other sensory modalities as well that you could be collecting from devices like Project ARIA. And this kind of input provides you an ability to ask very unique questions. For example, you could ask questions like, am I in a conversation? Who am I communicating with? Am I engaged in that conversation? am I having difficulty understanding these conversations? Only if you have these kind of multimodal sensory data, then you can ask these questions and be able to answer these questions as well. So one example from the audio team's research is Project Heimdall, in which the team used Project Aria devices, mounted OptiTrack markers on them, and then collected data sets with people with hearing loss and without hearing loss. And they tried to understand whether there is any difference in behavior of people when they're conversing in noisy environments, if they have hearing loss versus they don't have hearing loss. They were able to identify, one, collect 6-off data when how the head is moving when they're conversing in noisy environments. So these are different representations of what those results look like. At the end, what they found out that there is actually a delta between the behavior of people with hearing loss and without hearing loss when they're conversing in noisy environments. More specifically, they did discover that people with hearing loss lean in and look up more as you increase the background noise levels. Another example to inspire your own research, audio research using Project Aria devices, is this preliminary results from our teams, in which through the visual information you can track the face points, and through the eye tracking cameras you can identify where the user is looking at. If you have these kind of inputs, so essentially you have the 6-off trajectories coming from the devices, and you have the eye tracking input, you could ask more deeper questions like, do the eyes dwell when noise and hearing levels rise? Is the eye gaze more stable during effortful situations? So you could ask much more complex questions if you have these kind of inputs to start with. So these are just a couple of examples of the type of audio research that could be done if, one, you have the right rich sensor suite of data coming from the devices, and machine perception services on top of it, which provides you the fundamental building blocks to be able to do your own research. So if you'd like to interact with Project Aria, these are the 2 ways to do it. One, our data set is open sourced, is available for download. So this is the link and the QR code to be able to download the data set and open tools. And the second way is to get access to a Aria research kit. So essentially get access to one of these devices and the associated tooling and machine perception services by applying for the Aria academic program. And that is it. I'm happy to take any questions.
If you have a question, you can just raise your hand. I actually have a question myself. So I think this device has like multiple microphones on the around the microphone, around the glasses, right? Have you tested like how precise the microphone array can localize the sounding object in the space? Like, or is it actually that necessary, like, to put that many microphones on the small glasses?
So we started with 7 microphones on these glasses. The reason for choosing 7 microphones is because this is a research tool. So we wanted to have that optionality and space, such that we can experiment with different configurations. All the sensors on these devices are configurable. So you could configure it to be, just use 1 microphone or 5 microphones or 7 microphones to get the different level of accuracy for getting spatial audio or localizing a sound source. So the accuracy of the sound source will depend on the algorithm that you're using to capture that spatial audio. But essentially, the device provides you the capability of configurability such that you can configure it in any way.
Thanks. Any other questions? All right, if not, we can thank you all for the first speech.
Thank you.